So let's consider this idea of unambiguous data at the parameter level and how we can benefit from this if we're using a variational learning algorithm. So let's consider our data point from before, our subject, object, verb data point. And here we have two parameters with different values. Head directionality, where we can have head first versus head final, which head final is predicting object verb, and that's good. Head first is predicting verb object, doesn't match, right? Versus subject drop, where that's really just saying, must you have the subject or can you optionally drop it? And when you have the subject present, both options are compatible with that, right? So let's look at this. Here, we have two grammars that are compatible with this data point. So you're like, oh no, if I'm just looking for like the one true grammar, how do I tell, right? But if you're using a variational learning algorithm that's learning over parameter by parameter, if either of these two grammars were selected, head final would be rewarded in addition to whichever subject drop value was used. So you learn something about head finality being the right answer. And if either these grammars were selected, then head first would be punished because you wouldn't be able to, and whatever subject drop would be sort of along for the ride, but you would get pushed away from head first. So whether you're picking these and getting pushed towards head final or picking these and getting pushed away from head first, you're learning something because you're separating out the contributions of head first and subject drop in this example, right? So just to be a little bit more concrete, because this data point is unambiguous for head final in this world, grammars using that value would be rewarded. And so its probability as a parameter value over time would reach 1, right? And grammars that are using the head first value would be punished every time. And so its individual probability as a parameter value would approach 0 over time.